Hello there guys, and welcome back to another epic Inexorable video. In this video we're looking at sketching reciprocal graphs. What's a reciprocal? A reciprocal in maths is essentially something where you have, let's say, the reciprocal of 5 is 1/5. The reciprocal of 10 is 1/10. The reciprocal of a half is 2, okay? So it's basically the number that's, let me just show you. If we have a number, let's say it's 5, its reciprocal, let's call its reciprocal R for reciprocal. They need to multiply together, basically, a number and its reciprocal will always multiply together to make the number 1. So if we rearrange this equation, dividing both sides by 5, you end up with R equals 1/5, okay? And actually, in any case, if you have some number A, any number A, except 0, times R, where A is just some number and R is its reciprocal, that's equal to 1, which means the reciprocal of the number A is 1 over A, just dividing by A, okay? That looks like a Q or something, but it's an A. I've just sort of drawn another Q. 1 over A. So basically, what I'm getting at here is a reciprocal is like 1 over the number. That's GCSE knowledge, okay? So a reciprocal graph is like it's like a y, and it's in some way related to the reciprocal of x, or sort of a power of a reciprocal. So it could be y equals 1 over x squared, or something like that. But so this is a sort of reciprocal graph. This is y equals 1 over x, y equals 2 over x, 3 over x, a half over x, or that's 1 over 2x, or whatever you want. It could be negative, could be positive, could be anything. But weird things happen when we draw these graphs because there is a special number for x that we've sort of talked about where x is not allowed to be that number, okay? So what number here would you say that x is not allowed to be, just by looking at it? Well, it's the number 0, because you can't divide by 0. So if x was 0, you would have y equals 1 over 0, which is not allowed. So we can also say x is not allowed to be 0, okay? And you'll normally see that in a question. It will normally give you this, and we have talked about this before. Okay, so how do we actually draw this? Well, one thing is maybe we want to just go about sketching some points and see if we can figure out what this graph looks like. So let's do this. Let's find some coordinates. Let's investigate what's the value for y when x is 1. So I'm going to say one coordinate is 1. Okay, so when x is 1, we have 1 over 1. So 1, 1 is a point on the graph. So let's say 1, 1 is about here, right? 1, 1. Okay. What about when x is negative 1? Okay, so we'll say negative 1. Well, this is y equals 1 divided by negative 1, which is negative 1. Okay, so negative 1 is also on the graph. Okay, now this is going to take us all day if we want to sketch an infinite number of points, but let's just look at what happens when x is either really small or really big. Okay, let's say that x is like 1,000,000. Doesn't matter what the number is. Let's say x is 1,000,000. I won't even draw it, right? Let's say x is really big and it's like over here. It's somewhere over here, okay? What happens to y when x is like 1,000,000 or 1,000,000,000 or 1,000,000,000,000? This is 1 divided by a really big number. That means y is going to be really small because it's 1 divided by like 1,000,000. So we're going to have like 1,000,000 and then 1/1,000,000th, or 1,000,000,000 and then 1/1,000,000,000th. So actually it's going to be like down here. Likewise, let's choose a really small number like 0.00001. 1 divided by 0.000001 is actually a really big number. So when x is really small, i.e. just to the right of the x-axis, y is actually going to be really big. And you can try it yourself, but you're going to get the exact same numbers when you go slightly to the left of the x-axis, or slightly to the left of the y-axis rather, and a really big negative number. These are all going to be points. And it turns out you can do this with as many points as you want. You can link all of these up, and they look something like this and like this, okay? I haven't drawn that very well. I need to make sure I'm, doing accurate drawings for you guys. Okay, this is the graph. In general, y equals a over x, where a is a positive number. Any positive number. This is the graph, okay? So if you're in an exam and you wanted to sketch this, you would say, well, actually, this is just going to be 1. This is the graph of 1 over x. That's it. There are no intersections on this line at all, on this graph. They do not touch the x or y axis at all, okay? Think about it this way. You want to find the y-intercept. When do we have the y-intercept, guys? What value is 0? X, okay? So when we're on the y-axis, x is 0. Okay, let's set x equal to 0. Oh, wait. Can't set x equal to 0, which means there isn't a value for y when x is 0, which means there is no y-intercept. Okay, let's try and find the x-axis intercept. Let's try and find the roots of this equation. How do we do that? We set y equal to 0, right? Okay, seems fine enough. 0 equals 1 over x. Oh, we've got another problem. There is no number that you can divide 1 by to make 0. Doesn't work. You also can't rearrange this equation. Let's multiply both sides by x. Again, problem. You can't do this. There are no solutions to this equation either, which means there is no x value which satisfies this equation for when y equals 0. There are no intersections on this line at all. So what we do say though, and this is the notes, this is called an asymptote, okay? Asymptote. And you may have come across this in GCSE before. If you haven't, do not worry. We're going to tell you all about it. Basically, as I've written, an asymptote is a line which part of a graph approaches but never reaches. In this case, the asymptotes, there are 2 of them. One of them is the x-axis, the other one is the y-axis. The reason for this is because if you think about it, this line, which is the x-axis, is approached by the graph but never reached. This line goes on and on and on towards infinity, infinity, infinity. It will never actually touch the x-axis. Same with this. On and on and on and on and on. You can draw an infinitely long line. It will never, ever touch the x-axis. It will just get infinitely closer and closer and closer, but it will never touch it. Same thing with the y-axis. This thing just shoots up to infinity, never actually touching the y-axis. Same thing when we go down on the negative y-axis. We come down, this thing just shoots down to the depths of hell, never to touch the y-axis. So we call those things asymptotes, and normally we draw them with dashed lines, but we can't draw the asymptotes on this graph because they are the x and y axes. So we'd be drawing over another line, but you do this. So in this question, you would also have to say asymptotes at x equals 0 and y equals 0. The line x equals 0 is the y-axis. The line y equals 0 is the x-axis. Okay, so this is what you would say. That's it. Let's have a look at another example. Okay guys, so we've got another example here. This is the graph y equals negative 2 over x. Now one thing that you should not be thrown off by, and by the way, this is another case, x cannot be 0. You can't put a 0 where x is. It's not allowed, it's undefined because you're dividing by 0. Another thing that you need to notice is that it doesn't actually matter what this top term is. It doesn't matter, it doesn't change anything. It could be really big or really small. The actual shape of the graph will not change. The only way it will change is going between positive and negative. So if you have this negative, it will change the shape of the graph, but this thing, doesn't matter what it is, won't really change it. The bigger the number at the top is, the bigger you need to, like the sort of larger values you need. So let me just visually show you. If this is the graph of like 1 over x, right? Then the graph of 2 over x would be just be a bit further out, okay? So it'd be like this, and then it would be like this, okay? So this would be the line of like 2 over x, okay? So yeah, it's just, you need a slightly sort of bigger value for x for this thing to get near, but the asymptotes are the same. This thing approaches 0, or it approaches the line x equals 0, it approaches the line y equals 0, all the same. It just sort of takes longer to get there, okay? But that's not the question. The question is negative 2 over x, okay? So this is the important thing. If it's negative, it will indeed change the answer. So basically, this is just something that you need to remember. If it's negative, you just need to do the same graph, but instead of being in this quadrant and this quadrant, you're going to be in this quadrant and this quadrant. Okay, that's all you need to do. So you're going to draw like that. Again, not a brilliant drawing, but sort of, you know. And again, you would label this y equals negative 2 over x, and you'd say asymptotes at x equals 0 and y equals 0. The asymptotes are the same. This line and this line, same thing. If it's negative though, we do have a reflection. So a negative value here basically gives you a reflection in the x-axis, right? It's like it's been mirrored, because it used to be up here and down here, and it's just sort of been like mirrored, if that makes any sense, okay? We'll talk more about transformations of graphs, but for now, just if you see it's negative, you just need to go here and down here instead. Okay, so we're going to look at one more graph in this video, and then we're going to split this up into 2 parts, I think. But this is going to be the sketching of the graph y equals 1 over x minus 1. This is where things change, okay? Now, you might say, all right, we also need to say x equals, or doesn't equal 0, right? But that's actually not the case for this question. X in this graph is allowed to equal 0. Let x equal 0. Do it. You get 1 over 0 minus 1. That's just 1 over minus 1, which is just minus 1. That's totally fine. But there is another number that you cannot have. What number would make the bottom of the fraction equal to 0? The number 1. Because this would be 1 over 1 minus 1. 1 minus 1 is 0, and then you'd end up with 1 over 0. So in this one, x cannot equal 1. That's the thing. So it's not always x doesn't equal 0, it's x doesn't equal the number that you would put here to make the bottom of the fraction 0. In this question, it would be 1. If this was x minus 2, x would not be allowed to be 2, because that would be 2 minus 2, and so on, okay? So now we actually can look at sketching asymptotes, because the asymptotes are now not going to be exclusively on the coordinate axes. So I'll show you what I mean in a second. If x is not allowed to be 1, we get the exact same situation where we're sort of shooting up. I'll draw it like, is there a ruler around? Yes, there is. I'm going to use a ruler for this one, guys. We're going to say that this is going to be our asymptote. It's like a dotted line, okay? There you go. A pretty shoddy one, but one nonetheless. Now, exact same thing. This is the line 1. Looks like an 11, doesn't it? That's probably my fault. We're going to say this is the line x equals 1, okay? Now, what does the rest of the graph look like? Well, actually, there is still an asymptote on the y-axis, or sorry, on the x-axis, on the line y equals 0. That stays. But the asymptote now is here. The asymptote is on the line x equals 1, which is a vertical line at x equals 1, because x is always equal to 1 along this entire line, up to infinity, down to negative infinity, x always equal to 1, so this is the line x equals 1. Now here's the thing, this is just the same graph, but the asymptote is on the line x equals 1 instead of the line x equals 0, which is the y-axis. So we do the exact same thing, guys. We're going to draw our asymptote, or our line by the asymptote, shooting down over there like that. and we're going to draw the negative part, the negative branch, shooting down here, okay? So this is actually the exact same graph as the line or graph y equals 1 over x, but it's actually just been moved to the right by 1 unit, hasn't it? The entire graph has been shifted that way by 1. If this was the graph 1 over x plus 1, we would have gone this way instead, okay? And again, this all ties into transformations, which we will look at shortly, but that's essentially the premise, okay? And again, you can have this with negatives, so you can have y equals 1 over 1 minus x or something like that. But in general, this is what you need to know. Just try out questions with this stuff, guys. Try out questions, you'll get used to it. There's not much to remember, okay? It's just about, well, I suppose it is all just memory, but even then there's not much to remember. It's just the shape of this graph. Using logical intuition, what happens when I get very close to 1? If I have this graph, it's gonna shoot up. Try it, put into this, right? X equals 1.00001 or 0.99999. Put numbers that are really near to 1 and see what happens. It will make this shape, okay? So anyways, guys, thank you so much for watching. Split this into 2 parts so we can check out some other shapes of reciprocal graphs. Appreciate you guys watching. Like and share. Thank you for watching. See you in the next one, guys.